Can you even begin to picture a light show of epic proportions, orchestrated by Mother Nature herself, in the vast cosmos? Now get this, the northern lights, the awe-inspiring Aurora Borealis, can reach a staggering 640 kilometers in height. That's the equivalent of 2,000 Eiffel Towers stacked on top each other. Isn't that absolutely mind-blowing? This breathtaking spectacle, the Aurora Borealis, is a jaw-dropping fusion of science and art. It's the universe's most extravagant light show, splashing the heavens with the most radiant colors you could ever dream of. But there's more. Hidden beneath its mesmerizing beauty is a world of intriguing science. One that's often overshadowed by the sheer wonder it ignites and the countless myths and legends that have spun around it. But buckle up, because the truth is far more scientific and no less spectacular. The Aurora Borealis isn't just a random spectacle of lights, it's the result of mind-blowing cosmic reactions happening light years above us. It's a ballet of particles, an orchestra of magnetic fields, a majestic sign of the phenomenal forces at play the boundless cosmos. And that impressive height? That's because the Earth's magnetic field is guiding these charged particles towards the poles and into the sky-high heights of our atmosphere. We're talking about a height so massive, it's almost unfathomable. The epic saga of the Aurora Borealis kicks off a whopping 93 million miles away, right on the fiery surface of our very own sun. Can you believe that? Our sun, the powerhouse at the center of our solar system, is a bubbling cauldron of activity. Imagine this, its surface, known as the photosphere, churns with scorching plasma, heated to sizzling temperatures of about 10,000 degrees Fahrenheit. This intense heat serves up a chaotic mix of turbulence and magnetic activity. This magnetic frenzy can trigger sudden monstrous eruptions called solar flares. Picture solar flares as the sun's fits of rage unleashing colossal energy equivalent to millions of hydrogen bombs exploding all at once. And as if that wasn't enough, these solar flares come hand in hand with the ejection of electrically charged particles, an extraordinary phenomenon we call the solar wind. But don't be deceived, the solar wind isn't your everyday breeze. It's a ferocious stream of charged particles, primarily electrons and protons, that defy the sun's gravitational hold and race through space at mind-boggling speeds, hitting up to 500 miles per second. Now, that's faster than a New York to Los Angeles trip in less than 60 seconds. However, the sun doesn't release these particles uniformly. Instead, it shoots them out following a mysterious 11-year cycle. At the peak of this cycle, the solar wind is at its mightiest, and the sun is more prone to spew out mammoth solar flares. This hair-raising period is known as the solar, but you might wonder, how does all this cosmic drama relate to the Aurora Borealis? Here's the big reveal. These electrically charged particles from the sun are the stardust that births the auroras. The solar wind chauffeurs these particles across the staggering 93 million mile gap from the sun to Earth. So these particles embark on an incredible interstellar journey. But what happens when these celestial voyagers collide with Earth? Get this, our planet's magnetic field is not just an average shield, it's a superhero, protecting us from these high-energy particles. How awesome is that? Earth, our majestic home, is far more just a random rock floating in the cosmic ocean. It's an ever-changing, vibrant entity with its awe-inspiring magnetic field, also known as the mighty magnetosphere. This magnetosphere, folks, is like an invisible superpower that cocoons our planet, like an invisible cloak of protection. It's the unsung champion of our survival, standing up against the relentless barrage of high-energy particles that the sun throws our way, also known as the solar wind. Imagine this. These particles are loaded with tremendous energy, and if they had their way, reaching our planet's surface would cause mind-blowing damage to life as we know it. Now let's talk about the shape of our planet's superhero, the magnetosphere, resembling a teardrop with the tail pointing away from the sun, extending mind-boggling thousands of miles into space. It's an intricate, almost magical system, a cosmic shield if you like. It not only deflects most of the solar wind, but also channels some of these charged particles towards our planet's poles. You ask why? Well, the structure of Earth's magnetic field is such that it is weakest at the poles. This allows some of these electrifying particles to sneak into the magnetosphere and enter our planet's atmosphere near the north and south poles. Just picture this, as these particles embark on a journey towards the poles, they follow the Earth's magnetic field lines. It's much like sliding down an interstellar slide, with the particles being the thrill seekers and the magnetic field lines being the slides directing them towards a phenomenal light show of their own creation. These particles, invisible to the naked eye, travel in their millions, a cosmic swarm buzzing towards the Earth's poles. As they collide with different gases in our atmosphere, they put on a show of lights that is nothing short of astonishing, a cosmic ballet that we are lucky enough to observe. Now you might ask, what turns these invisible particles into the breathtaking spectacle of lights we know as the Aurora Borealis? Get ready for a color explosion. When these charged particles spectacularly crash into gases in our atmosphere, they create an explosion of color. It's like a universal fireworks display. So, are you curious to know the exciting science behind the grand spectacle of the Aurora Borealis? Brace yourselves and secure your space helmets. We're about to take a thrilling dive into the cosmic chemistry of colors. The mesmerizing color show we witness in an aurora is nothing short of fascinating. It's an intricate dance between charged particles from the sun and the gases in our atmosphere. And the colors you see? They all depend on two major factors: the type-excited gas molecules and the altitude of the spectacular collision. Picture the atmosphere as a massive, layered cake. Each layer, with its unique composition and density, plays a vital role in the grandeur of the auroral displays. Starting at the bottom layer, right next to Earth, it's mainly nitrogen and oxygen. Charged particles slamming into these gases at lower altitudes, between approximately 60 and 200 kilometers. It's all about the green and red lights. As we rocket higher, beyond 200 kilometers, the atmosphere's mix changes. In this upper layer, charged particles dance with atomic oxygen, sparking it to emit a breathtaking red light. But what about the rarer blue and purplish-red auroras? These are born from collisions happening at incredibly high altitudes where the atmosphere is thinner. Here, charged particles can stir up molecular nitrogen, which then beams out blue and purplish-red light. So, the whirlwind of colors we observe during an aurora directly mirrors the atmospheric conditions at different heights and the specific gases present. It's like nature's own magic chemistry set, with each chemical reaction painting a different color. So next time you're captivated by the of an aurora, remember you're not just watching a light show, you're part of a cosmic dance party, a performance of particles and gases, each adding their unique move to nature's grand choreography, according to the laws of physics. Remember, the Aurora Borealis is more than just a light show. It's a cosmic ballet of particles and gases dancing to the mesmerizing rhythm of nature's laws. Well, brace yourselves, folks. There you have it. The Aurora Borealis, a cosmic dance spectacularly orchestrated by the sun and performed by whirling particles on the Earth's atmospheric stage. It's a spectacle like no other. We've embarked on a thrilling journey, right from the blazing heart of our sun, the birthplace of solar winds, darting through the infinite expanse of space and finally landing at our planet's magnetic field, none other than Earth's very own superhero shield. Witness with awe these solar winds, supercharged with pure energy, crashing into oxygen and nitrogen in our atmosphere, causing them to burst into brilliant hues of green, purple and red. What a sight to behold. This dazzling spectacle is not merely a feast for our eyes, rather a vibrant testament to the complex and riveting processes that are unfolding in the heart of the cosmos. It's a radiant display of the interplay between solar energy and our planet's magnetic field, a mesmerizing dance that paints our night sky with a stunning spectrum of colors.